Hello, this is John from caveofprogramming.com. In this tutorial we're going to start looking at lambda expressions in C++11. This is one of the initially more baffling features in C++11, although it's a very nice feature. So we're going to break it down into several tutorials here. So let's in this tutorial we're going to take a look at a simple example of a lambda expression, and we're going to look at passing that to a function. So earlier in the course we saw function pointers, which are a way of passing code to a function, and for that matter storing a function in a variable in effect. And we've also seen functors, which are another way of basically achieving the same thing. C++11 gives you a way of doing this that's even a bit nicer, but sometimes you're going to probably still want to use function pointers or functors, but in many situations where you just need a simple function that you need to be able to pass around, you can use a lambda expression. So a lambda expression looks kind of like a bit of a bracket fest. So we're going to start with two square brackets here, and these are a kind of distinctive feature of lambda expressions, which will enable you to recognize a lambda expression when you see it. We're going to see what you can actually do with the different brackets that we're about to use, but first I'm going to show you the simplest possible example, which does look like a sort of bracket party. So we've got two square brackets there, then we've got two round brackets there, an opening and closing pair, and then we've got two curly brackets like that, and then we can put a semicolon in. So this, I haven't actually ever tried running this, but that probably is a valid lambda expression. Now, what we normally do at the very least with all these brackets is we put some code in the curly parentheses. So of course in C++, usually a pair of curly parentheses are intended to surround code, and indeed that's what we use this for. So let's put some code in here. Let's just say hello. Now this defines a kind of like an anonymous function. So it's a lambda expression. It's a function, really, sort of a function that doesn't have a name. And it's not going to do anything in itself. So we've defined a lambda expression, but we're not doing anything with it. In fact, I get a error here. That's just because I missed off the semicolon. So this is a valid lambda expression, but we're not doing anything with it. We're not actually running this code. We're just defining a function that doesn't have a name. And indeed you can see this looks a lot like the definition of a function, except instead of having a function name, and for that matter a return type, we've just got a pair of square brackets. Apart from that, it looks a lot like the definition of a function. So one thing we can do with this is store it in a variable. So I can use auto here, and let's call this, we'll give this variable the name func, and I can set it equal to this lot. So now we've got an anonymous function. It has no name, and we're storing that function. We're storing a reference to that function of some kind in this variable func, and we can then call it using func, or whatever we call it. It could be func, could be anything, just in the normal way that you'd expect if you've seen the videos on function pointers. So we just put the round brackets in to actually call it, and this will actually work. There are some things that are best not to ask, and one of them is, what is the type of this variable? You can ask that question if you want. It's some kind of functor, but the exact type, it varies from lambda expression to lambda expression, and unless you want to delve in to really deeply into the technical details, you don't need to worry about it. So it's better just to use auto with a lambda expression like this in C++11. Don't forget you've got to enable your compiler for C++11 or use a C++11 compatible compiler for this, but basically it's common to use auto with the variable name. So now we've got a variable that is some kind of reference to this anonymous function, and we can call the function like this. We could even call it directly. So if we didn't have any of this, we could just put the round calling brackets here. Whoops, that's not what I want. Let's get the right syntax there. And that would actually call the lambda expression. Now it really is a menagerie of brackets, but there's not usually any real reason to do that. It's more common that you're going to want to store this in a variable like this. Now we can pass that to a function, which is kind of the real purpose of this really, and a function can call this code. So how do we do that? Well, lambda expressions are compatible with function pointers. So if we say, let's create a function called test. Now this is a function which actually has a void return type because we're not returning anything. C++ can usually infer, or often infer, the return type of a lambda expression, and here, because we're not returning anything, it's inferring a void return type. So the return type is going to be void. Then, of course, as we've seen before, we need a pair of round brackets which contains a star and the name that we want to give to this function pointer. Let's call it, let's call it pfunc. I won't call it func again, just to reduce confusion, but it could be called absolutely anything. And then after that, in round brackets, we need to specify the parameters that the function that we want this to point to takes. This has no parameters. We're going to see later that we can put parameters in there in around brackets, but we won't do for now. So this is a function pointer called pfunc to a function which has a void return type and takes no parameters. And we can then execute this function in here by calling pfunc round brackets. So again, the round brackets call the function. And then we can call that function and pass our lambda expression to it like this, as if it was a function pointer. So that works, and we get hello again. Another thing that we could do, which is useful for some situations, but you don't want to do this with too much code, is to call the function and specify the lambda expression directly. Let's just copy this, paste it directly in there, and let's say hello again. So this is going to work. We're calling a function that expects a function pointer. The function pointer is compatible with this lambda expression. It has a void return type, takes no parameters. So we can pass this in directly, like define it and pass it directly in. So if we run this, we get hello again. Okay, so I think that's enough for this tutorial. We're going to look at more in the next tutorial. So a good thing to do is practice this yourself. Try all of these different things. Try defining a simple lambda expression and setting an auto variable equal to that, and try calling that directly, and then try passing it to a function which accepts a function pointer of the appropriate type. Also try calling that function then and passing in a lambda expression directly, so you can see that working. This looks pretty baffling when you first see it, but again, the secret is in the typing. When you've typed it a few times, it starts to really kind of come down to earth for you. And we're going to look at what you can do with these other brackets in subsequent tutorials. So until next time, happy coding.